Number 21 here in 4.2 is kind of easing you into the second part of this homework where they're going to ask you to do all this stuff, but without walking you through it step by step. Here in 21, they've given you 4 different things to come up with, but this is really what you guys are going to need to do anyway in future problems. So they've given you this quadratic function right here, x squared minus 4x plus 1. They want you to first find it says find the critical point C, which suggests there's only going to be one. We'll talk about why that's the case in a second, and compute f of c. So how do you find a critical point? You find your derivative first, set it equal to 0 and solve, or find where it's undefined. So our derivative here is going to be a 2x minus 4. Now, the reason they said find the critical point C and compute it right there is because they're suggesting at least there's only going to be one. Well, that shouldn't surprise you. F of x is a quadratic function, which means its derivative is 1 degree less than that. It'll be linear, and a linear function can only have 1, 0 right there. So looking at that one pretty quickly here, guys, we're going to get x equals 2, and they said go ahead and call that c. Not that it matters that much, but okay. So we get a critical value of x equals 2, so I guess that's our c value right there. And then f of c, or f of 2, we would put that back into the original function. 2 squared would be 4, minus 8 would be negative 4, plus 1 would be negative 3. So we found our c value, and we found f of c. So there's c, and here's f of c. So I think we're done with part A. B, they've kind of artificially introduced some endpoints right here. I wish they had written them up here. I think that would have made a little bit more sense. But they just want us to look at this function on an interval here from 0 to 4. And extreme values can occur at critical points, which we found here in part A, but they can also occur at endpoints. So let's do f of 0. That's just a quick and easy 1. And then f of 4, well, this is convenient. That's 16 minus 16. Those cancel out, and we end up with 1 as well. So that's all they wanted us to do in B, find the values of f of x at 0 and 4. Moving on to C then, let's determine the minimum and the maximum. I guess I can slide this up a little. The min and the max of this function on that interval. Well, remember, guys, a max or a min can only occur at critical points and endpoints. And very conveniently, right here, I've got all 3 of those things. My critical point at the point 2, negative 3, and then my endpoints there when x was 0 and 4. So the maximum is going to be the highest number out of those 3, and it's a tie with 1. Our minimum is the lowest value of all of them, which is going to be a negative 3. So that's a simple question that sometimes people try to make too complicated. Determine the min and the max of this function on that interval. They're asking for y values there, guys. The maximum y value you'll ever get is 1, and the minimum is negative 3. And then, okay, so for part D, that was ugly. They're kind of asking you the same question here again. Extreme values would really just take us into what we're dealing with right there in terms of absolute max and absolute min, and if we had any relatives. But with this one right here, I'm not really sure that that one occurs. So the extreme values right here, we have an absolute maximum value we just came up with of 1, and then we have an absolute minimum value to this function at negative 3. And the way they ask the question, I don't take that to mean that they want any more information other than that, like where these things occur. So I'm looking at their solution right here, and it just says the maximum value of the function is 1, and the minimum value is, they wrote negative 2. That's not right, because in part C, they just said right there the minimum value is negative 3. Oh, wait a minute. I think I misread something right here. The maximum and minimum. Okay, I'm sorry. Point D is asking us for the extreme values just on the interval here from 0 to 1. Aha. Sorry, should have checked that earlier. So what that means, boy, that kind of changes the problem right here. All right, so I take all that back then. This is not the same question as C. All right, if we take a look at the critical point that we found, the only critical point was at x equals 2 right here, but that is not in this domain right here. So there is no critical point that occurs within this range here, this domain I should say, from 0 to 1. What we would need then would be to check our endpoints. So I'm looking right over here. We would need to check f of 0, and that hasn't changed from right there, guys. F of 0 is still equal to 1, but we also would need to check f of 1 because they've changed the window where we're looking at on this problem. So putting a 1 back into this function right here, which I don't believe we've done yet, 1 minus 4 is negative 3 plus 1. That's where that value of negative 2 came from. So here you go then, guys. Extreme values on the interval from 0 to 1 are absolute maximum. The highest of these two numbers is 1, and our absolute minimum is the lower of those two numbers, negative 2. So I'm sorry, I didn't do a good job of reading the directions, although it does seem weird they just randomly changed the interval here on part D, but there you go. On the interval from 0 to 1, your absolute maximum value is 1, and your absolute minimum value is negative 2. And that is number 21.